So welcome to Web Lab Week 2. We had a very intense first week in the sense of we taught a lot of stuff. So I'm going to try to recap everything in 30 minutes. So we'll see how that goes. A quick announcement. We released the skeleton for coding your website. I should hide this. But yeah, there's a Piazza post on how to use our skeleton and get started with actually coding up your website. Because you guys finish your milestone 1, so you have your design. So the next milestone is literally just building the minimum viable version of your website. And I believe that is next Tuesday. So there's a lot of time between now and then. And there's also a giant hackathon on Friday, which is essentially extended office hours. So we have office hours tonight, Wednesday night, and then the giant office hours on Friday. All are good times where you can come get help on your website, and just come to office hours just to work on your website. And we'll be there to answer questions and help think of ideas and things like that. And yeah, speaking of office hours, there are office hours tonight. So feel free to show up. And we put together this little review resource of the first week. If you guys want to pop over to that link. If not, the slides are always here, so you can always pop over to the link. But we talk about the front end, the back end. So that might help. But okay, let's start with a little recap of everything from week 1. So I'm going to start with front end and back end, because we started by doing a bunch of React stuff. And then we started talking about the server. And yeah, so let's talk about that. So the front end is when users go onto your website. They could be anywhere. They pull out their laptop, and when they type in your URL in their browser, what they see is the front end code. It's what's visible to the user. It is what makes your site look good. It's basically the user-facing part of the website. And as you can see on the laptops, it's our React code. So all of our components, our HTML, JavaScript, CSS, that's all front-end stuff. And then there's the backend, the server. And the backend is kind of like the central being that connects all the front ends, in the sense of the front ends or the clients can all send requests to the server and tell it to add a story or add a comment. And then the server keeps track of all these things, all the information, the collective like hub of everything on your website. And then it sends over things to the clients whenever they request things. So a way you can remember it is the backend code is behind the scenes. You don't see it. And the front end code is in front of you. So yeah, a quick little summary of front end versus back end. And what does it look like in code? I don't know how visible this is. I wonder if there's a light setting. But is it visible? No? Yes. Yeah. Wow. Nice. But the front end code is our React. So all of the React components go into their own file, like app.js or any other component name .js. So this stuff is the front end, your React code. And then the back end is basically a bunch of routes or endpoints that you tell your server how to respond to. So with these 5 functions, our server can now respond to requests from the clients to /test, to /stories, /comments. So I assume get stories would get all of the stories, and get comment might get all of the comments for a specific story. And it also teaches the server how to add a new story with the post method. So post a story might add a new story, and the post route to /comment might add a new comment. So coding up these functions lets you tell the server how to respond to different requests from your clients. So now the clients from anywhere in the world can say, please add a new comment, please add a new story. And then the client sends over that request to the central server. The server does it and then gets back to the client with any information. So one thing to note from here is that you don't actually need a front end in your website, in the sense of the backend has all the functionality. So if you really wanted, you could use Catbook by just manually sending over the post requests and the get requests. So like, rather than logging onto the website to see all of the stories, you could just make a get request to the server and get them yourself. You don't need to use the website. But imagine if every user of your website had to manually send their own get and push requests. That would be terrible. So basically, our front end just makes our website easier to use. And the backend has all of the features, functionality. So I thought I have a little picture demonstrating the backend is the thing behind the scenes, which you don't see, which makes the website possible. Thought this is funny. And yeah, so we code up our front end in React and our back end in, I guess we didn't emphasize the name of the language that much, but it's called Node. It's basically just JavaScript. Both of them are JavaScript, but they're just different ways of writing JavaScript. And then sometimes our server will also need to talk to our database. Like if you're running a store, sometimes you'll need to go to the warehouse to get your stuff. The database is just a larger place to store all of your information. And the server will often communicate with the database to get things like getting all the stories or getting one specific story. And for a little review of databases, there's just 3 parts or 2 parts. I don't remember how many I had, but there's some number of things that you have to do. First, you have to write your schemas. So you have to tell Mongo what do things in the database look like. And here we're telling it we have stories and we have comments. And each story will have a creator name and content. And each comment will have a creator name, a parent, and content. And this is one way to get all the stories from the database. You just use the story.find function. And if you pass in nothing, it gets all of the stories. And this is how you add a new story. You create a new story object, which we defined in our schema. And then you just save it. And that creates a new story. Okay, that's, oh yeah, you have a question? Yeah, schema is, it's kind of like the structure of the object in the sense of it tells you the fields, but it doesn't tell you what the values are. Okay, let's talk about React. So React is it's our front end language. So we have our design and we want to turn that into code. And one way to do that is divide it into components. So we start out with app, which is our whole website. We can divide it into navbar, feed, sidebar. We can divide it even more. And we can make a tree out of our components. And if you see the code, you basically just include the components you want in your code. So the app is made up of the navbar, the feed, and the sidebar. And each of those is defined in their own file, a .js file. And then you have props. These are your inputs to your components. And you have state, which is internal information inside of your component that you can update. So yeah, these are the three first things we learned about component or about React. You have components, props, and state. And then for the next stuff, I want to bring back this weather app example. So I have a little component that's the weather app, and it says the weather. And so we're going to try to get the weather through a GET request. So we're going to get the result of the GET request in our constant called actual weather. And then we're going to set the weather to be our result. But there's something wrong with this. Does anyone remember? Why can we not do this? Yeah? Yeah, exactly. So the GET request takes some time. It's an asynchronous function, which means that the line of getting the weather runs, and then it goes to the set weather line, but the get never finished. It just moves on without finishing. So we don't actually have actual weather yet. So yeah, we have to wait for the get request to finish first. So we fix it. And we use this .then function, and that allows you to wait for the get request to finish before moving on and setting the weather. There's still a problem with this, though. Does anyone have any ideas? If you run this code, it'll probably say something like, there are infinite renders of this component. It'll be some weird infinite loop error. Any thoughts? Yeah? Exactly, yeah. So the thing with React is whenever you change the state or the props, it's going to rerun everything because it needs to update the state and update the props. So it'll just rerun all the code of the component. So what happens is when you set the weather, it reruns everything again, including the get request. So it will get the weather again and try to set it. And that'll be an infinite loop. So it's important to remember that everything reruns whenever the state and the prop change. So, or whenever you update the state or update a prop. So the solution is to just plop it in a useEffect. That's the whole point of useEffect. We generally use it for getting data and stuff because we want to do that only once. And any code we put into this useEffect with an empty array after it will run only once at the beginning. And it won't run again whenever the state or props are updated. So that way we get the weather only once. And this is another example of using useEffect. We want to get songs and then we set the songs after we get the result from the GET request. And we put it all in the useEffect. That's an example of passing in parameters to our GET request. So sometimes we might want to specify some stuff for our backend. And the backend might return different things depending on what genre we pass in or what year we pass in. So yeah, here's a quick little summary of the things we learned about React so far. Okay, now I'm going to talk about how to connect everything together because there's a lot of info there, but it's not really obvious. Like, I want to start coding my website. How do I actually do all of this? There's a lot going on. So I think there's 4 main steps that work for turning your web app into code. And the first thing to do is figure out what you need to store in the database. And then you want to figure out what your server needs to be able to do. What kind of requests will you be making to your server? And then moving to the front end, you want to divide your design into components, easily manageable little pieces. And then maybe figure out the props and the state and your get and post requests. So for the next section, I'm going to use this little example app. I can show you guys. It's just a very little chat app type thing. Exit full screen. But I'm going to show you guys how to make this app where you can just message. I don't know if you guys caught the link, but you can see people can message. That's the main feature. Okay, so how do you make this? Step 1, we have to store something in the database. And one thing we need to store are messages, because that's the whole thing on the website. They're messages. So we should probably store those in our database. So the first thing to do is add a schema for everything you want to store. Here is a message schema. All it is you figure out what you want your message to store. So you might want a name, like who sent the message. You might want the text of the message. I'll skip this for now. And then we need to figure out what we want our server to be able to do. So any thoughts on what our server needs to be able to do in this app? What endpoints would we need? Any guesses? Well, there's 2 main things. We would want to, like when you first go onto the website, you type in the URL and immediately you need to have all the messages. because that's what's displayed on the page. So we need to get all the messages. That's the first thing. And then the second thing is you need to be able to make a new message. So when you click post, you type in a message, you hit post, it needs to be able to add a new message. Okay, we did step 2. So you can take that result and write your backend. In the sense, you don't have to fill in the methods yet, but you can write out that you need your get request to all messages to be able to get all of the messages. And you need your post request to new message to add a new message. So you can write all of your endpoints out, which you figured out that you need in your app. And then you can implement them. You don't even need to have done any React yet. You can just straight up implement the endpoints. A quick little explanation is that message.find with the curly braces in it gets all the messages from Mongo. And then you take the result and you send it back. The res.send is how you send things back to the client who made the request. And then the post new message, what we do is we create a new message variable, which is a new message object. And we define message in the schema, so we know that it needs a name and it needs some text. And the text we can have as an input to our post request. We can have the client pass in the text that they want, and then we can have that be posted. And then we wrote our backend already. We wrote our database stuff already. That's 2/3 of the website already done. So now we just have to write the front end. And we can first divide this into components. I think there's some confusion in that some people were wondering, what is the right way to divide things into components? Like, how do you know when you're done? How do you know when you need to split it up more? And the answer is there is no right way. It's just however you want to organize it. You could, if you wanted, write everything in one component, but that would defeat the purpose of React, because then things might be very annoying to have to keep track of. There might be a lot of repeated code. So the division I've chosen is just have everything in the app component, except have each of these green boxes be a message component. And then also separate out the new message area to be its own component. And then we have to figure out how to code up these components. So one thing to try to think of is, where do we want to actually use our get and post requests that we coded up in our backend? And I guess one thought is we want to have the post request, the add a new message, be in our new message component, because that's where the button is to make a new post. And then we need all of the messages in each message component. So it probably makes the most sense to just get all the messages in our app component and then pass each individual message down to its own message component. Are there other ways to organize this? Yeah, probably, but this made the most sense to me. So that's how I chose to organize it. And then we can just code up our components. So here is a quick description of how app was done. I just had a list of messages and state. And then I have the useEffect code where I make a GET request to the endpoint that we just wrote, where we get all the messages from the server. And then once we get them back, I set them into a state. So now messages is equal to all the messages from the server. And then I return two divs or two things. First, the new message component, the little like add a new message area. And then a bunch of message components where I pass the text and the name to each one. This is using the map function. And then this is the code of each of those individual components. The message component it's hidden by my zoom. But it literally just prints the name, a colon, and then the text. Obviously, we can change up this component to make it look nicer. And then the new message component is basically an input, so a little place to input text, and then a button. And when you click the button, it makes a post request to the endpoint that we just wrote in our backend. And that's it. That's the entire web app. From start to finish, from the design to figuring out what we needed in our database, figuring out what endpoints we needed in the server. We wrote the endpoints in the server, and then figuring out the components. So we first wrote the message schema. Then we wrote our backend endpoints. And then we wrote our three components, app, and then the message component, and the make a new message component. I put a little mini example in the slides that if you want, you can check out later. But yeah, that's it for the review. And I believe Dan's next with authentication.